Okay, factoring trig expressions. This works about the way you'd expect. If you have 8 here and 4 here, the greatest common factor from those is a 4 that you can take out, and that leaves you with 2 tan a plus 1. The lesson is you don't divide what's inside the trig function by anything. You aren't expected to, and in fact you must not. So if you have something like, just do a side example here. Suppose you had 8 tan 12a plus 4. This 12 doesn't matter in the slightest when you're deciding what to factor out. You cannot get at this. It's inside the tangent function. Think of this tangent as an impenetrable brick. You can't take anything out of it. So again, all you could take out would be a 4, and you'd be left with 2 tan 12a plus 1. So don't try to factor things out from inside the trig function. It won't work. And you don't need to in any case. Now let's clear that out and carry on. Sine squared x minus 3 sine x. If you want, well, I'll do this real quick and then I'll show you an option that you might like. You can take a common factor of sine x out of this, and that leaves you with sine squared x divided by sine x is sine x, and 3 sine x divided by sine x is just 3. So that's your factored form. When you have a trig expression and it's a little bit complicated like that, sometimes you can rewrite it without the trig expressions in it. Just use a symbol to stand in for them. So say instead of sine, just put s. So sine squared x, you would just put s squared, and then minus 3 sine x becomes minus 3s. That's called suppressing the trig functions, and it gets some of the clutter out of the way and makes it easier for you to see what has to happen. You can factor this form, and then once you're done all your factoring, you go, oh wait, but s is actually standing for sine x, and this s inside is also standing in for sine x. You may not need to do this for most problems, but with the really ugly complex ones, it can be nice to get the trig out of your face for a minute so you can concentrate on the factoring, and then you just put it in later. I'll just randomly do this, suppressing the trig functions every so often to remind you that it's an option. 4 sine squared x minus 1. It's a binomial. It's got a minus in the middle. This has a nice square root. This has a nice square root. This is a difference of squares. And when you factor a difference of squares, you get 2 sets of brackets, one with a plus, one with a minus. 4 sine squared x would have come from 2 sine x times 2 sine x. Then the 1 would have come from 1 times 1. So there's your factored form. Quickly look at these just to confirm that you can't factor them any further, and you can't. So that's the end of the line for that one. Cosecant squared x minus 3 cosecant x minus 28. I'm going to suppress the cosecants here just to make this a little clearer. Cosecant squared x minus 3 cosecant x minus 28. It's a quadratic. We need two numbers that add up to minus 3 and multiply to minus 28. I'm thinking 7 and 4. If we use c minus 7, c plus 4, or perhaps the other order, it doesn't matter all that much, that would be our factored form. And last thing I need to do to finish it up, remember that c is standing in for cosecant x, so you're not actually done until you change it back to cosecant x minus 7, cosecant x plus 4. And last one, again I'm going to let c stand in for cosine, so 2c squared plus 7c minus 4, that's a little better. I'm doing this by decomposition. I hope you're familiar with that. If not, I'm sure you have a guess and check method that will crack this quadratic. But when I do these, I think 2 times negative 4 is negative 8. What are two numbers that will add up to 7 and multiply to negative 8? Answer, 8 and negative 1. So 2c squared plus 8c minus 1c minus 4. Factor by grouping. This is extremely fast decomposition, and if you're not quite following how this factoring works, but you're interested in it, please contact your instructor. They'll be happy to show it to you. It's an excellent technique. And here it tells us that our factored form is c plus 4 to c minus 1. But wait, don't stop there. Remember, c is cosine x. So when we put that back in, we get cosine x plus 4 and 2 cosine x minus 1. All done. So if you can do these without suppressing the trig functions, great. If you find this is a little cluttered and hard to concentrate on, just replace the trig operators with a simpler symbol, and it makes it easier for you to focus on what's important.